Now, Richard worked through something. He took the derivative of this function, and he made an argument that the derivative of this function, of course, is equal to this. That's an easy derivative to take. And then we just collect terms, and we end up with a coefficient of e to the negative c over 2mt, which isn't real easy to read over here, of negative c over 2mb plus c minus c times negative c over 2mt. And of course, the double negative here can give us a positive. And let me pause and make sure that that's all kosher. Now, I'm not getting a lot of good sense when I proceed with this. Okay, I want to set x prime equal to 0, which means that we're finding an extreme point for x, which is the position. So that would be like finding an extreme point if the graph looks like this, and there would be our extreme point. That's possible if the graph doesn't look like this, that the graph just, for positive t, damps down toward 0. And in fact, it's known that if the initial condition has the velocity being greater than or equal to 0, the system won't have this behavior. But if the initial velocity is negative, it will. Still, I'm not getting that out of these equations. I'm getting something very much like the opposite. So let's look at the equations and see how we get this. So we're trying to find this critical point. So we're going to set x prime equal to 0, and that's very simple. The e to the negative c over 2mt is 0, is 1, because the negative c over 2mt is 0, which means that this expression here has to be 0. So we just solve this expression, set it equal to 0, and solve for t. I'm just setting what's in these parentheses here equal to 0. And it's very straightforward. We get c, and I'm using ct for critical. Okay? T critical is negative b over c plus 2m over c. Now, t critical greater than 0, which is what we have to have it over here. And let me note that if we will have a critical point, this thing has to give us a critical point on the negative side, if not on the positive. On one side and one side only, since we only have one value for the critical point. Okay, so critical point, critical time is greater than 0 implies that this, which is a positive quantity, be greater than b over c. Okay, b over c could, I guess, be positive or negative, but in a minute we're going to see that to get a critical point greater than 0, it looks like it has to be positive, because if this is greater than this, then, well, c over b has to be, now let's see if I got my sign right here. If we multiply by c and divide by 2m, then as long as c is greater than 0, and that might be the kicker there. Let me check something. Okay, well, if c is greater than 0, then we have this. If c is less than 0, then because to get this, we multiplied this by c. We're going to have this, but this is kind of automatically true as long as b is positive. Then we get c over b less than little c over 2m, but since this is a positive quantity, that's doesn't really give us any additional information. Okay, something's wrong with the signs here. I can't find it. I've got myself locked in and don't have any more time to deal with it. If we go up here and look at the derivatives of x, x prime of 0 is this. So that's like our initial velocity. And x prime of 0 equals 0 if and only if c over b is little c over 2m. Incidentally, I've got a couple of c's here. I got this c, which is the drag coefficient, and this c, which is our arbitrary coefficient. And I've distinguished them by putting a little bar on this c, so you can see where the big C is and the little c is. I've separated them. So this is a big C, this is a little c. Okay, well, x prime 0 equals 0 under these circumstances. X prime 0 is negative then if this is negative, and that occurs, and you can easily check that, if C over B is less than C over 2m. Now, the condition here and the condition here should be the same. C over B should not be greater than 2m. C over 2m here should not be less than C over 2m here at the same time. They should both be like this, and I don't see where it's wrong. So you can look at that if you like.